Problem says an educator wants to see if there's a relationship between the number of absences for a student and the student's final grade. Use the data below to find the variance for the random error of the least squares prediction line. So we have the data below. There's absences and the final grade. There are 6 pairs of values, right? And what we want to do first, the very first thing we need to do is get the summary values that we normally have from a layout of data like this. What I mean by summary values is we want to create an X column. In this case, we'll let the absences be the X, and we're going to let the final grade be the Y, because we want to predict final grades from absences, right? And so the first step we need to do is do some summary information. And I'm going to do that for us here, or I've done that for us, I should say, and it's been laid out for you here on this sheet of paper. Now, what I'm showing you here is essentially the calculations that I did to come up with the totals that we need for each column of data. If you notice, the first 2 columns are just X and Y, right? Just X and Y. The 2 rows that we had here, I just made them into columns. Just copied everything down, keeping them paired up as they came to me, right? Then from there, I totaled those values, right? So I totaled the columns to come up with these numbers here. Then I took every value in the X column and I squared it. That's the next step. And then I totaled that column. Then I took every value in the Y column, I squared it, and I got that total, right? And then finally I multiplied X times Y and got a column there from that, and then totaled those things. So that is the very first step you have to do. I've done that all for us so that we'd be a little faster, that we can move on with the problem. From there, the only other thing you have to do is give these totals names. So what I mean by that is name this value what it would be, right? It's the sum of the X column. This one is the sum of the Y column. This one was the sum of the X squared column. This guy was the sum of the Y squared column. And lastly, this guy here is the summation of the X, Y column. Okay, so we have the totals now. Now, the next step we want to do is to figure out the formula for the S squared value, right? So for that sample variance, what's the formula? So the formula is actually something called the SSE. So we're going to say S squared is equal to the SSE over the degrees of freedom. The degrees of freedom. All right, the degrees of freedom for this problem turns out to be n minus 2, because we're going to be estimating 2 parameters with the data, so n minus 2. And the sum of square error value, that actually is something we're going to discuss in a moment to see how to calculate that. But essentially, that's the formula for S squared. So what we want to do next now is to go and figure out how to calculate these items. What we're going to have to do to calculate SSE is we're going to have to first come up with some important sum of square values. So we're going to need to do a whole bunch of sum of squared calculations. The calculations that we're going to have to do start with sum of square for xx. Then we'll do the sum of square for the mixed term xy, and we'll finish with the sum of squares for yy. And once we calculate these 3 sum of square values, we can then move on to plug in everything we need for SSE. And at that point, we'll discuss the specific formula as to how to get SSE. So let's start by calculating these items, and let's remember the formulas for each one. For the sum of square for xx, we have to do basically the sum of x squared minus the sum of x quantity squared all over n. That's the sum of square for xx. The sum of square for xy is going to be the sum of the x times y column minus the sum of x times the sum of y all over n. And then for this last one, which is one that we haven't calculated yet, it's the sum of squares for yy. That's very easy to do. It's the sum of y squared, right, minus the sum of y quantity squared all over n. So it's very similar to the sum of square for xx. It's just we have y's instead of x's. Okay, so we have all those values, so we're ready to plug the numbers in. Let's start out by calculating the sum of square for xx value. Okay, so the formula for this requires us to take the sum of the x squared value, which is 337, minus the sum of x quantity squared, that's 37 squared, over n. N is the number of original ordered pairs we started with. We had 1, 2, 3, 4, 5, 6 original ordered pairs. All right, we'll work that out in a second. Let's do this formula first, the sum of squares for the mixed term xy, and see what that gives us. So the sum of squares for xy is the sum of the xy term, which is 2,682, minus the sum of x times the sum of y. Sum of x is 37. The sum of y is 482. We'll divide that by, again, 6, the number of ordered pairs we started with. Then we'll have the sum of squares for the y term. Sum of squares y. And that is, again, the sum of y squared, which is going to be 39,526. Then we're going to minus the sum of the y term squared, which is going to be 482 squared, divided by 6. Okay, so let's work out those three values right now with the calculator and see what they give us. Okay, so starting with the first one there, we will have 337 minus 37 squared divided by 6. And when you're done, you get 108.83 repeating. 108.83 repeating. The next one is 2,682 minus 37 times 482 divided by 6. And we're done with that, you get negative 290.3 repeating. Negative 290.3 repeating. All right, then after that, we're going to do 39,526 minus 482 squared divided by 6. When we're done with that, we get 805.3 repeating. 805.3 repeating. All right, so those are our three sum of square values. There's a quantity we're going to need for our formula, which is going to be the estimate for the slope, beta 1 hat. So let's go ahead and calculate that value now. Beta 1 hat has the following formula. It's SSXY over SSXX, right? The mixed term over the x term. We plug that in, let's see what we get. We're going to have negative 290.3 repeating divided by 108.83 repeating. Let's see what that ends up giving us there. Minus 290.33333 divided by 108.833333. All right, when you're done, you get an answer of minus 2.667 ... So minus 2.667 on and on and on, right? I'm going to store that in my calculator as the variable x. And by doing that, I will have it for later without having to round it. Okay, now, once we have that established, then we have to calculate our sum of square error quantity. We're going to need that quantity to fill in s squared. So sum of squares for the error, SSE, the error sum of squares in other words, has the following formula. We're going to have to work out the formula by doing the sum of squares y minus the slope beta 1 hat times the sum of squares for the mixed term xy. Okay, so let's fill in what we know here. We have SSYY, that's 805.3 repeating. Then it'll be minus times beta 1 hat. Now beta 1 hat is the minus 2.667 ... value, right? Times SSXY, the mixed term, which is also negative, minus 290.3 repeating. All right, now notice there are three negatives here, so that's just going to work out to be one negative, right? And then the product of these two numbers. So you could actually say that this is the same as 805.3 repeating minus 2.667 ... times 290.3 repeating, right? So that's how we'll work it out in our calculator. Okay, so let's do that now quickly. We're going to say 805.33333 minus 2.667 times 290.33333. And when we're done with that, we get the answer 31.014 or so, right? So SSE works out to be, SSE turns out to be 31.014 dot, right? Okay, so 31.014 dot. All right, now I'm going to store that number into our calculator as x because we're going to need that number in a moment. So I stored that in my calculator. I have it handy. Let's go and see how to finish the problem. We just need to get s squared in this problem. So we're going to take SSE, which is this number we just calculated, and divide it by the degrees of freedom, which is simply n minus 2 here. So for us to finish this problem, all that we're required to do is to say that s squared is equal to SSE over n minus 2. SSE is 31.014 dot over 6 minus 2. And 6 minus 2, of course, is 4. So when you do that, you end up with the value we just had, x divided by 4, and that'll work out to be 7.754. 7.754 if rounded to 3 places. So that's your variance, your estimate of the variance.